Hello folks, welcome to today's video. Today we'll be continuing with our circle geometry unit, and we will be talking about tangent lines and how do we make some calculations using tangent lines. So a tangent line, what is a tangent line? Well, a tangent line is a line that touches a circle in exactly one spot. So if you thought about it like this, if I had a circle and I put something flat, like a piece of wood or something, on top of that circle, it would rest there right on kind of one spot on that circle where it would kind of fall away from that piece of wood on both sides of it, right? So that flat surface, that piece of wood, is what we call a tangent line, right? It is a line that touches my circle at exactly one spot. And where it touches my circle is what we call a point of tangency. So the point of tangency is the point where the tangent line touches your circle at exactly one of those spots. And we could draw tangent lines and point tangencies anywhere around my circle, right? So I have one here, I would have one down here, I'd have one over here, and so on and so on. Now there is a special property when I take a radius and I attach it or I draw it to that point of tangency. What ends up happening is when you have a radius drawn to the point of tangency, the angle between the radius and the tangent line measures 90 degrees. So this angle right here would be 90, and this one here would be 90, and this one down here would be, well, you guessed it, 90 degrees. So it's a nice little property that ends up meaning that I can do some calculations with that 90 degrees. So for example, if this is my diagram, right, where we have, in each diagram, point O is the center of the circle, which lines are tangents. So if we looked at these two lines, let's distinguish between which is a tangent and which is not. Or a couple of lines actually, right? So here, line MN, is that a tangent? Well, no, that is a diameter. Line OP, is that a tangent? No, that's a radius. But line QR, that is your tangent line, right? Because it passes through our circle, it just touches right here and then bounces off. And then if I looked at question B here, again, line OD, that's a radius. Line AB, that's a different kind of line. We haven't talked about that one yet, but that one's called a chord. And line CE, that is your tangent. Okay, now let's take a look at this question over here. Point P is a point of tangency, and O is the center of each circle. Determine the value of angle X. So this angle right here at point P, what is the value of that angle? Well, if PQ is a tangent line, and P is my point of tangency, and OP is my radius, again, what ends up happening is when you draw a radius to a point of tangent, then that will always measure 90 degrees. So that X here is 90 degrees. Okay, let's take a look at the next one here. So again, PQ, there's my line of tangent, or my tangent line. Point P here is my point of tangency. OP is my radius. So does that mean my X is 90 degrees? Well, no, my X isn't 90 degrees, but this angle here is 90 degrees. And if we think back to the previous video, what do we know about the angles inside of a triangle? They have to add up to give me 180. So what I can do is I can find that angle X by taking my 180 and subtracting the other two angles that I already know. And if I do that, I get X is 67 degrees. Okay? And then same thing here, right? So again, PQ is my tangent line, PO is my radius, point P is my point of tangency, so the angle between them is 90. And again, X is this angle down here, so if I know two angles inside of my triangle, then I can take those two known angles and I can subtract them from 180, and I find that X is 43 degrees. Okay, so really kind of simple problem there. Once we know the value of an angle, we just take them away from 180 to find any missing angles, right? So by knowing that this thing is 90 degrees, it just gives us a second piece of information that we can then work with. All right, well, how else could we use our known angle there? So here's another example. Point P is a point of tangency, and O is the center of our circle. Determine the value of A. So here, again, OP, there's our radius, PQ, there's our tangent, so here's my 90 degrees, and we're being asked to find not an angle this time, but a side length. Well, what happens when I have a right angle triangle? Well, when I have a right angle triangle, the Pythagorean theorem now applies. So I can find the value of A by saying A squared is going to be equal to 3 squared plus 4 squared. Or A squared is going to be equal to 9 plus 16, or a squared, is going to be equal to 25, which means that a is going to be equal to the square root of 25, which is 5. So a in this case is not, sorry, a is not a is 5 units. Okay, so what ends up happening is when I look at these radius and tangent lines, yes, they give me triangles that contain 90 degrees. Well, what ends up happening is if I have a triangle that contains 90 degrees, that's a right angle triangle, and now the Pythagorean theorem applies. So we can start using that Pythagorean theorem to find many pieces of information. So here's another example. Point T is a point of tangency, and O is the center. So here's my point of tangency, here's my O. So there's my radius, and QR is my tangent line, and here we're being asked to find angles E and D. So again, it's now you have to stop and think, all right, what do I need to do? Do I need to use Pythagorean theorem? Do I need to use the fact that it adds up to 180? Is there some combination of the two? Right, so that's what we need to figure out. So the first thing I would do is I would always label the 90 degrees. So there's the 90 degrees there, and there's a second one over here, right? There's two 90 degrees going on here. So if I'm looking for a missing angle, that's kind of your cue or your indicator to say, okay, if it's a missing angle, that means I'm probably using the fact that the three angles inside a triangle add up to give me 180. So that means angle D is going to be equal to 180 minus 90 minus 28, which is 62 degrees. And angle E is going to be on the other side. So again, E is going to be equal to 180 minus 90 minus 180 minus 90 minus 35, which is 55 degrees. Okay? So let's take a look at why we care, right? So it's always good to see kind of, okay, here are some numbers and some diagrams, and let's find an answer. But what happens when we take that math and we apply it to an application, to some scenario, right? So here's an example. An airplane A is cruising at an altitude of 9,000 meters. A cross-section of the Earth, so what that means is if I were to take the Earth and kind of cut it right in half and look at the two-dimensional diagram that makes that up, with a radius of approximately 6,400 kilometers, so the distance from the center of the Earth to the surface is 6,400 kilometers. So a passenger wonders how far she is from point H on the horizon. So she's looking from the airplane, she's looking out at the horizon, and she's seeing kind of where the Earth almost curves away, right? She's seeing just kind of this last little point right here, and she can't see anything behind it because that is my point of tangency with her eyesight. So if I wanted to find the distance that she is away from that point, well, I can do that by using my property. So if I were to draw in an extra line here, if I would draw in this line right here, this is my radius to that point of tangency. And what we know is that that is 90 degrees. So there's my right angle triangle. So I can find this missing distance right here by using my Pythagorean theorem. A squared plus b squared equals c squared. Now, there's still some missing information that we have to infer from the question. And what it means to infer something is to not be told it specifically, but to take the information that we're given and assume or guess or know from that information what it's supposed to be. So if I know that the distance from the center of the Earth to the ground is 6,400 kilometers, that distance is true anywhere around this circle. So what that means is that this distance right here is also 6,400 kilometers. Now, before I get into doing my calculations, there's one more thing we have to consider, and that is units. If this is in kilometers and this is in meters, and we try to use those two numbers, we are going to get something that is wrong. What we need to do is make sure that they are in the same units first. So 9,000 meters is 9 kilometers. Okay, and again, the reason it's 9 is because the conversion kilo means 1,000. So it takes 1,000 meters to make a kilometer. So 9,000 meters will make 9 kilometers. Okay? So now, if we looked at the distance from the middle of the Earth to the airplane as being one of my side lengths, right? And the distance from the middle of the Earth to the surface of the Earth being a second side length, and the distance from the plane to that point on the horizon is the third side length, I now have my right angle triangle where we're missing one of the legs. So what we know now is that 9 plus 6,400, so 6,409 squared minus 6,400 squared will be equal to that missing distance squared, right? So if we grab our calculator in this case, because I'm not going to do this one by hand, right? So 6,409 squared minus 6,400 squared is x squared is going to be equal to 115,281. So then what I can do is I can find the value of x by taking the square root of my 115,281, which is approximately 340 kilometers. Okay, so approximately 340 kilometers. Okay, so this is the power of circle geometry, right? Once we have these properties, these things that that we can calculate and we can do, then we can look at real world examples or actual applications. And the nice thing is if you think about it, if you stop and think for a second, how many circles and triangles can you think of in the real world? Outside of the classroom, even inside the classroom. And I'm sure if you stopped and you thought about it, the list would go on and on and on. Okay, so what we find is that there are lots and lots of application to this type of math, and we're going to look at a few more of these as this unit goes on. Okay, so that's it for today's video, and I will see you all in the next one.